All right, so we want to talk about now just not a goodness of fit test, but we want to talk about inference when you have a two-way table, okay? And if you think about a two-way table, this one has multiple columns for what type of wine people ordered at a restaurant and what type of music was playing in the background, okay? So there's the type of music playing, the type of wine that was ordered, and we're wondering, like, does background music influence wine purchases? And there are these numbers here, and it looks like when there's French music playing, lots of people order French. And when there's other music playing, still people order French, but almost no one orders Italian. It's like French makes people not order Italian music, and really it almost looks like they didn't order any wine at all, okay? But they did order a lot more Italian than they usually do in the other categories. So it seems like there might be an association here that the choice of music influences wine purchases, okay? And these smaller numbers might just have to do with they didn't play Italian music as long. So we don't know why this 31 is smaller, 99, 113. But we're wondering, like, is there a difference between these? And if you think about it, we have the wine that was ordered, and I might make stacked bar graphs. It would look a little bit prettier, okay? But you can see wine ordered when there's no music playing, French music playing, Italian music playing, okay? And it looks like there's a difference in these distributions, right? The Italian column is fluctuating a lot. The French column goes from 35 up to 52, back down to 35%, okay? So how would our null hypothesis sound? Well, it's really multiple different ones if you tried to break it down, and we're going to combine it into one chi-square test, okay? The distribution of wine types for no music is the same as French, or no music is the same as Italian, or French is the same as Italian. Or alternatively, there's a difference in at least one of these pairs, but like there's multiple sort of comparisons. We want to compare none to French, none to Italian, French to Italian. Can we do it all in one fell swoop? The answer is yes. Okay. We could say the distribution of the response variable, the wine that people purchase, is the same in all the different populations, the populations of music types. Okay. And the alternative, or in this case, the proportion of each wine type sold are the same in all three populations of music that they were listening to. And notice our chi-square test statistic doesn't change. It's still observed minus expected squared divided by expected, all added together, okay? But you may be wondering, like, how many people do I expect to listen to order French wine when there's no music playing? And it turns out that it's the row total, this 99, times the column total, this 88, divided by the total, okay? 243. It's hidden behind my my screen here. I don't know if I can hide me. There you go. Okay. And so 99 times 84 divided by 243 would be the expected count for this particular column, which if you grab a quick calculator, you can see 99 times 84 divided by 243. Okay. We get 34.2. So we got 30. We were expecting 34.22. So if I do sort of, let's do 30 minus the answer squared divided by the answer, okay? So we're doing 30 minus that 34.22 squared divided by 34.22. This is how much it would contribute to my test statistic, which does not seem very, very significant, okay? And so we would do that for every single block on this table, and they each contribute a little bit to some total of a test statistic that then we would need to compare to our chi-square distribution, okay? And so how big is unusual? That's depending on degrees of freedom and stuff like that. And we'll talk a little bit more about that in the next video. So good luck and farewell.